Hello guys and welcome to today's class. For today's class, I'll be trying to provide the solution to the chemistry exam past questions, of course, for inorganic chemistry. This is for 2019-2020 year or 2019-2020 session. This is for 2019/2020 session, and there are about 40 objective questions and some theory. But for this video, I'll be answering the first 20 objective questions. Okay, so for this exam, you have barely 1 hour 45 minutes for both the objective and the theory session. All right, so I'll try to answer this as fast as I can. Let's start with the section A here. The past question is not too clear. That's number one. Also please avoid the already circled work. Okay, doesn't mean they're correct. It's just somebody's script. All right, so avoid the circled one. Let's just learn together. All right, so let's get started. Section A. Which of the following are elements? You have number one, CO, II, small o, IIIC, IV, O2, V, CO2. All right. If this is not clear enough, please go to your settings and increase your video quality so that you can see this clearly. All right. If it's not clear enough for you. All right, let's get started. Section A, I. Which of the following are elements? CO, IIC, small o, IIIC, IV, O2, V, CO2. So the first thing you have here is carbon monoxide, right? The first thing you have here is carbon monoxide, which is actually a compound, so that's not an element. C small o, what you have here is called cobalt, which is an element. So II is an element. C, you have C there, which is what? Carbon. So C, carbon, is also an element. IV, you have O2. O2 is actually a molecule of oxygen. All right, so we can't really call O2 an element. Instead, we'll call it a molecule. Then V, you have CO2. CO2 is carbon dioxide, which is a compound. So the elements you have here is II and III. So for this question here, the correct option is option D. That is II and III. So option D, this one here, is your correct option. Question number 2. Which statement is not consistent with Rutherford's nuclear theory as it was originally stated? Now, before we answer this, let me give you a brief background. Now, here's what to note. Rutherford's model of the atom proposes that an atom consists of very small, very dense very dense, positively charged nuclei surrounded by clouds of electrons at relatively great distance from the nuclei. Some key points from Rutherford's experiment include number one, the volume of the atom is mostly empty space. Number two, nucleus of the atom is small, tiny, and positively charged. Number three, a neutral atom has equal number of protons and electrons. And number four, lithium atom is neutral. So from this, we can see that the only one that did not match that is option B, which is neutral sodium atom contains more electrons than protons. That's not true. All right. For every neutral atom, we have equal number of protons and electrons. So number two, the answer is B. That is the one that is not consistent with Rutherford's nuclear theory. All right, number three, which is true of this ion? Now let me write that out. What you have there is AM. You have AM. At the top you have 2, 4, 3. Bottom left you have 95. Top right you have 3 plus. All right, so if you look at the option, you're seeing PEN, all true. P means number of protons, E means number of electrons, and N means number of neutrons. So let's analyze this. First things first, what you have here, AM, is actually called americium. All right, americium is an element. So how do we get number of protons? Very simple. Number of protons is simply what you have here. which is called the atomic number. In other words, number of protons P is equal to 95. That's simple. Next up, what you have here is called the mass number, and mass number is simply number of protons plus neutrons. So I'm saying protons plus neutrons gives you 243. Now, if this equation is true, we already have number of protons as 95. So in place of protons here, I'll just put 95. So I'm saying that 95 plus n is equal to 243. I have this. So move this man here over here. What do you have? It means that n is equal to 243. So 95 comes over here, becomes minus 95. And if I do this math here, if I do 243 minus 95, let me get my calculator. All right, 243 minus 95. What I have there is 148. So I'm having 148 as neutrons. Next up, I'm going to get my electrons. How do I get electrons? That's simple. Now, to get electrons, you focus on this part here that has charges. So what to note is this: if there's no charge here, then you have that number of protons is equal to number of electrons. That's a neutral atom, as previously stated in Rutherford's model of the atom. But this one has a charge, and the charge here is positive. What does positive mean? When an atom is positively charged, it means it has lost an electron. So let's look at this. If this man was neutral, I will have that number of protons, which is 95, should be equal to number of electrons, which is 95 here. But then 3 plus here means it has lost 3 electrons. So from my electrons here, I'll remove 3. So if I remove 3 electrons, it becomes 95 minus 3, which gives you 92. So from here, it means that protons is equal to number of protons is 95. Number of neutrons is 148 and number of electrons is 92. So let's see the option that matches this. So from this, we can see that the option that matches this is option D. Yep. So option D says 95P, that's 95 protons, which is correct. 92E, which is 92 electrons, which is correct. And then 148N. So D is the correct option. That's it. All right, moving on. Let's get to number 4. Number 4 says a sample of an ionic compound containing iron and chlorine is analyzed and found to have a molar mass of 127 gram per mole. The charge in brackets combining power of the ion in the compound is dash. All right, let's get this man solved. Okay, so to solve this, first thing you should notice that I'm combining iron. Let's have iron and chlorine. So they said it's an ionic compound. So let's get the ions. For iron, iron has 2 ions. The first one is ion 2, which is Fe2 plus. The second one is ion 3, which is Fe3 plus. So any of these would combine with chlorine. Chlorine just has 1 ion, which is Cl minus. So it means I have 2 possible answers. Either ion 2 or ion 3 would be the correct option. So let's try using ion 2 and see if we'll have the answer. If I'm using ion 2, it means that ion 2, Fe2 plus, combines with chlorine, Cl minus. Now, here's what to note. When 2 ions combine to form a compound, the first task is this. For you to know that that this compound is possible is that you look at the charges. When the charges are opposite, it means they can combine. Why? Because opposite charges attract. So these 2 atoms will be attracted to one another because they have opposite charges. So when they attract, what happens? I'll be having Fe here. The number here comes down here. Okay. This is minus, but the number here is minus 1. So I'm having something that looks like Fe1. Okay, when it's 1, we don't have to write it, so it's just Fe. Then chlorine, I'm having Cl there. This 2 here comes down. Don't forget to say the number will come down, but the signs will be there. So the sign here is the sign here is 2 plus. So I'm taking just the number. The 2 comes down here. So the idea is very simple, that they will exchange pairs ignoring their signs. So for chlorine, the 1 moved here and came down, which is Fe1, same thing as Fe here. And for iron, the 2 moved down this way, so it became Cl2. You can ignore the sign. Alright, so if I have this, I'm not having FeCl2. I have this. Okay, so what next? They said here in that question number 4, they said the molar mass is 127. So I'll check if this molar mass is 127, it means the combining power of ion here is Fe2 plus, but that's 2. So if it's not 127, I'll try with 3 and see my answer. Alright, so when it comes to getting combining the molar mass of this, for ion, note that for ion, the molar mass of ion is 56. So it becomes, get the molar mass of this compound here, ion is 56 plus, is a constant of course. For chlorine, the molar mass of chlorine is 35.5. But since you have 2 atoms of chlorine, it becomes times 2, alright? Times 2 because I have 2 attached to the chlorine here, as you can see. So if I combine this, I'm having 56 plus, multiply this. What do I have there? So if I multiply this, I have my answer as 71. Alright, so combine this, 56 plus 71, and your answer is actually 127 gram per mole. So if you go back to the question here, what was given here was 127, and we used ion 2. So the answer here is 2 plus. Yeah, so that's the combining power of ion there. Next one there is question 5. Let's look at question 5. Question 5 says, which statement is true? A, when an atom loses an electron, it becomes negatively charged. That's wrong. Actually, when an atom loses electron, it becomes positively charged. B says columns in the periodic table are referred to as period, right? Columns in a periodic table are called groups. So you have group 1, group 2, group 3. So that's wrong. The answer is actually group. C says C14, that's carbon 14, and N14, that's nitrogen 14, have identical proton neutron proton ratio. That's wrong. That's not true. If you do the number of protons, the number of neutrons to protons in carbon 14 and nitrogen 14, they are not the same. So it's not true. D, neutrons have neither mass nor charge. That's not true. Neutrons they don't have a charge, they are neutral, but they have a mass. So neutrons do not have charge, that's true, but they have mass. So you saying that they don't have neither mass nor charge is wrong. E says isotopes of an element have the same number of protons. Of course, isotopes of an element have the same atomic number but different mass number. And since atomic number is defined or since atomic number is defined or decided by number of protons. So if isotopes have the same atomic number, hence we can say they have the same number of protons. So the answer is correct, E. So E is the answer to this. Alright, next up, number 6. The amount N. So when you see N there, N means number of moles actually. So that's chemistry. When you see small n in chemistry, it means number of moles. So the amount in bracket number of moles of ammonia NH3 present in 4.60 L, which is liter, comma 2.30 m, which is molarity of ammonia is. So they're asking you for the number of moles. They've given you volume, they're giving you molarity. So how do we solve this? Alright, so to solve this, here's what to note. Note that molarity M is equal to number of moles all over volume. It's this simple. Of course, all over 1 to make the small n to be subject to the formula. This multiplies this. So I have that n times 1 is equal to, this multiplies this. That's M times V. N times 1 is N is equal to MV. So it means I can get the number of moles by multiplying the molarity with the volume. What's the molarity here? 2.30 m. That's the molarity. So it becomes 2.30 times V. V is the volume. Volume here is in liters, 4.6. So times 4.60. If I multiply this, 2.30 times 4.60, my answer gives me 10.58. 10.58. By the way, N is measured in mole, MOL. That's your short form, right? That's like the SI unit. Some will use MOLE, which is still fine. So my answer is 10.58. What is the option there? 10.58. So it's not here. So the answer becomes none of the above, right? There's no 10.58. A is 8.58, 7.58, 0.52. The answer is E, none of the above. All right. So the next thing here, number 7 says, among the elements B, C, A, F, H, E, A, L, P, which is boron, calcium, fluorine, helium, aluminium, and phosphorus, which two elements exhibit the greatest similarity in chemical properties? All right. All right. So how do we get the elements that exhibit the greatest similarity in chemical properties? What do we do? Before we talk about chemical properties now, here's what to note. So note this. Note that elements in the same group have the same valence electrons and therefore similar chemical properties. Elements in the same period have different properties. So we can know the elements that have the same chemical properties by looking at the elements that are in the same group. And how do we know the elements in the same group? Very simple. We look at their valence electron. That means to get this question here, I'll have to look at the valence electron of each of the elements. So let's get that man sorted. Alright, so listen out the elements given. We have boron, B. We have calcium, Ca. We have fluorine, F. We have helium, He. We have aluminium, Al. We have phosphorus, P. So we have this. Alright, so with this now, let's get their electronic configuration. So from there we can also get their valence electrons. Alright, let's start with boron. Boron is atomic number 5. Calcium is atomic number 20. Fluorine is atomic number 9. Helium is atomic number 2. Aluminium is atomic number 13. And then, of course, phosphorus is atomic number 15. So for each of these, we'll do their electronic configuration using the KLMN shell concept. All right. All right. We've already treated that in our previous class. All right. So let's get this. For boron, the electronic configuration will be 2, 3. For calcium, I would have 2, 8, 8, 2. For fluorine, I'll have 2, 7. For helium, I would have 2. For aluminium, I will have 2, 8, 3. For phosphorus, I would have 2, 8, 5. Alright, so for this now, we'll look at those elements that have the same, the valence electrons. That means the last numbers are the same. So one of it would be this one here, boron, and this one here, aluminium. That's this. So you can see that boron and aluminium have the same valence electron. That's 3, 3. So that's a correct option. Also, we have this one here, calcium, that's Ca having 2, and of course helium, that's Ca having 2, helium, excuse me, that's He, valence electron. So I have He. So let me see, is there any option as B, boron and aluminium? If I look at this, so yes, there's boron and carbon, which is and calcium, which is wrong. Calcium and aluminium, which is wrong. Boron and aluminium, which is correct. So yep, that's the correct answer. Helium and phosphorus, that's wrong. Helium and fluorine, also that's wrong. So my answer there is option C, boron and aluminium. So I have this. Question 8. Which of the following is a chemical change? Alright, which of the following is a chemical change? A says water vapor that condenses on a cold surface. So, okay, before then, when we say chemical change, we mean a kind of change that is irreversible, all right? A change that cannot be reversed. Water vapor that condenses on a cold surface can be reversed. How? If I heat the water, it will go back to what is vapor state. So, it's a physical change. B says the melting of butter when placed under sun. If butter is being melted when placed under sun, simply take that butter, put inside a cold room or a fridge, it would solidify. So it's a reversible process. C says the evaporation of sodium chloride solution to dryness. Well, if you put it in a closed path, right, it can still, or if you condense it, it's possible for it to also condense too. So it's reversible. D says the burning of lamp oil, and E says forming of dew on a cold night. Of course, if dew forms on a cold night, when it's day, it will evaporate. And then at night again, if the night is cold, it will still form dew again. So the only one here that is not reversible, that's a chemical change here, is D. So 8, the burning of lamp oil. When lamp oil is being burnt, it cannot be reversed. You have to get a new oil. So the answer is D. All right, E, the electron was discovered by Dash. Who discovered electron? You have these options. Okay, let me help you out with this. So first thing to notice this. The first one you have here is Aro Millikan, which is Robert Millikan. He discovered the mass slash charge of an electron using his oil drop experiment. So that was not him. J.J. Thomson. J.J. Thomson was the man that discovered electron actually by using the cathode ray experiment. So the answer is J.J. Thomson. So note that J.J. Thomson discovered the electrons. I'll just highlight the other ones here just in case it's been changed. See, it says Ernest Rutherford. Now note that Ernest Rutherford was the man that discovered protons. All right. The next one here is James Chadwick. Chadwick was the man that discovered neutron. Please take note. Next one is J. Dalton. John Dalton. John Dalton propounded some theory known as Dalton's atomic theory. All right, so he tried to explain how an atom works, although some of his theories were being modified. Then M. Faraday, that's Michael Faraday, was the man that discovered electricity. So Michael Faraday discovered the concept of electromagnetic induction, right, or electrolysis. So the correct answer there is J.J. Thomson. All right, look at number 10 here. Number 10 here says, what is the volume of hexane left unreacted when 7 cm cube of hexane is treated with 38 cm cube of oxygen based on the reaction? You have this. This is a question on limiting an excess reagent. All right, I'll leave a link to my complete playlist on inorganic chemistry in the description of this video. All right, so later check the description of this video. You'll see a link to all my classes on inorganic chemistry for free. All right, that's on my other channel anyways. All right, so check, you see a class on limiting an excess reagent. That's where this question falls under. But then let's solve this. How do we solve this? To solve this question here, here's what to note. The first thing is this. They said, what is the volume of hexane? They also mentioned oxygen. So they mentioned two things there. Hexane. hexane, which is C6H14, and then oxygen, which is O2. So the first thing to look out for is this. You'd have about 4 compounds here. My 4 compounds are hexane. Okay, let me highlight that. This one here, C6H14, hexane, O2, oxygen, CO2, carbon dioxide, H2O, water. In every question like this, they will ask you for 2. In this case here, the 2 asked for were, or the 2 mentioned were hexane and oxygen. So I'll focus on them. My next task is to make sure that the reaction is balanced. So in this case, let's check. I have on my reactant left hand side, I have for carbon, I have 2 times 6, which is 12. Come to product, I have 12 here times 1, which is 12. So carbon is balanced. Come to hydrogen, I have 2 times 14, which is 28. Come to my right hand side, react the product part, I have 14 times 2, which is also 28. So hydrogen is also balanced. Come to oxygen. On the left hand side, I have 19 times 2, which is 38. On the right hand side, I have this one first, 12 times 2, which is 24. So you first of all have this one gives you 24 of oxygen, plus I'm having 14 here times 1, which gives you 14. I'm talking about this one here, this H2O here. So 14 times 1 gives you 14. If I combine them, it gives you 38. That means the equation is balanced. So if it's not balanced, you have to balance it first. For a balanced equation, if I look at molar ratio, by molar ratio I mean take coefficients here. For hexane, this one here, the number attached to it is 2. Alright, so it becomes 2 is to, for oxygen I have 19 attached to it, okay, is to, for CO2, carbon dioxide, I have 12, is to, for H2O, what I have 14. But since I'm focusing on just hexane and oxygen, I'll discard these two. So it means from a balanced equation of reaction, I need 2 cm cube, talking about volume, or 2 moles. All right, so moles and volume are used interchangeably. Please note that if they ask you for moles, the same concept. If they ask you for volume, the same concept. This one says what's the volume? I'm using volume, the same thing. If they had asked you for mole, use the same concept. So 2 of hexane will react with 19 of oxygen. I have this. All right, that's your first task. Next up says, what is the volume of hexane left unreacted? So in this case, hexane was left unreacted. The one left unreacted, please call it X. All right, call it X. Then they said, when 7 cm cube of hexane is treated with 38 cm cube of oxygen. So under oxygen, I'll put my 38 there. So you have this. So this is how to solve this question. Please note that the one that they said was left, the one that you were asked to find when it's left unreacted, call it X. All right, let's solve this. To solve this, you just cross multiply, becomes this times this, and then this times this. So it means X times 19 is equal to 2 times 38. I'm just simply cross multiplying. From here, x times 19 gives you 19x is equal to 2 times 38. That's 76. Divide here by 19 to get x. Divide here by 19. So I'll have that x is equal to, so I'm having 76 over 19, and my answer is 4. So x is 4. Now come back to the question here. They said, what is the volume of hexane left when 7 cm cube? So it means for 18 cm cube of oxygen, I only require 4 cm cube. Now, I only require 4 cm cube of hexane to react with oxygen, but I was given 7 cm cube. So the question is this: if I have 7 cm cube of hexane left, but I used only 4, what is left? What is left becomes simply 7 minus 4, and that gives you 3 cm cube. So 3 cm cube should be what is left. If I look at this, the correct option there would be option C, which is 3 cm cube. Alright, so that's how you solve this. Alright, so I've answered the first 10 questions here for this particular session. We'll look at the next 10 in our next section. Alright. So if you enjoyed this video, please make sure you like this video and subscribe to this channel. Also hit the notification button so you get notified when we want to do the now question 11 to question 20. So we'll take them in turns. All right, so this is how you can simply encourage me to make more videos like this. Like this video, subscribe to this channel if you're yet to subscribe. Also, leave a comment. Tell us if you enjoyed the video and suggest other things you want to see. And finally, please share this video to your friends so that they can also learn. Thank you and see you in the next class where we'll continue with this revision.